Take a look at this dress. What colors do you see? I want you to pause this video right now and think. Are you seeing white and gold, or are you seeing black and blue? You might think, what is this question? It is clear. Well, if you can ask the same question to someone next to you, you might be surprised. For now, don't overthink it. Rely on immediate perception. If you were anywhere near the internet in February of 2015, you probably already know exactly what we are looking at. A seemingly ordinary, low-quality photograph of a dress was posted online, and within hours, it completely fractured the world into two fiercely divided camps. People were genuinely confused, sometimes even angry that their friends and family could look at the exact same screen and see entirely different colors. It became one of the most viral phenomena in internet history. But it was so much more than just the fleeting pop culture meme. Without people realizing it at the time, this single overexposed photograph sparked a massive real-time psychological experiment on a global scale. It forced us, one more time, to reveal a shocking truth about human neurology. The colors you perceive are not objectively real. Instead, they are intricate, calculated guesses made by your brain. To understand what is happening, we first have to dismantle a very common misconception about how human vision actually works. Most of us go through life assuming our eyes function like high-definition video cameras, objectively recording the exact wavelengths of light bouncing off objects and sending a perfectly accurate live feed straight to our minds. But that is fundamentally incorrect. Your eyes are not objective light meters. In reality, the light that reaches your retina is a messy, complicated combination of two completely different things: the actual color of the object you are looking at, and the color of the light that happens to be shining on it. Think about a standard white piece of paper. If you look at that paper outdoors under a clear blue sky, it reflects a slightly bluish light. If you take that same piece of paper indoors and read it under a warm desk lamp, it reflects a yellowish-orange light. The physical light entering your eye has completely changed, yet you never consciously perceive the paper as changing colors. You just see a white piece of paper. This neurological feature is called color constancy. Your brain acts as a real-time phone editor. It automatically analyzes your surrounding environment, makes a split-second assumption about the color of the ambient light, and then actively subtracts that light bias from the object you are focusing on. It happens instantly and entirely subconsciously, allowing you to recognize the world around you regardless of the time of day or weather. But as we are able to see, this evolutionary superpower has a very specific vulnerability. Now, let's put this concept of color constancy to the ultimate test. Take a look at this graphic. On the left, we see a dress that appears unmistakably black and blue, seemingly bathed in a warm yellowish light. On the right, we see what looks like a white and gold dress, cast in cool bluish shadow. Your brain is perfectly happy accepting these as two distinct garments, but prepare to have your reality shattered. If we were to isolate the center strips of both dresses, the very fabric you are focusing on right now, and completely strip away the background context, something weird is revealed. The pixel color codes for those center strips are exactly the same. Mathematically and objectively, they are identical shades of a muddy gold and a light periwinkle. There is no blue and black dress on the left, and there is no white and gold dress on the right. There is only one set of colors being presented to your eyes. The entire illusion is being manufactured inside your head. Because the simulated background lighting is different in each panel, your brain is forcefully applying two completely different color constancy filters to the exact same pixels. It is the ultimate visual proof that the context, not physical reality, dictates the colors we perceive. So exactly how is your brain putting off this localized magic trick? It all comes down to a process we can call illuminant subtraction. Look at the left side of the graphics again. The background provides clear visual cues that the scene is flooded with warm yellow light. Your visual cortex processes this contextual information and immediately acts on it. It assumes that the yellowish tint on dress is just the illumination from the room, not the actual pigment of the fabric itself. So it essentially runs a subconscious color correction program, subtracting that warm yellow light from the image. When your brain pulls yellow away from that muddy brownish gold pixel, it leaves behind a deep dark black. When it pulls the warm light away from the light periwinkle, it registers a vibrant blue. Thus, the black and blue dress is born in your mind. Now shift your focus to the right side of the graphic. Here, the background completely changes the narrative. It tells your brain that the dress is sitting in a cool dark blue shadow. Following the exact same evolutionary logic, your brain attempts to correct the image by subtracting the blue illuminant. When you strip the bluish tint away from the light periwinkle pixel, your mind perceives a brilliant white. When you subtract the blue from the muddy gold, it becomes a bright, luminous yellow gold. The physical pixels on your screen haven't changed a single bit, but the calculation your brain performs on them has completely inverted. You aren't actually seeing the colors on the screen. You are seeing the reminder of a subconscious math equation. This explains our perfectly constructed graphic, but it brings us to the ultimate question. Why did the original 2015 photograph cause such a massive global disagreement? The answer lies in ambiguity. Unlike the clear visual clues in our graphic, the original viral photo of the dress was terrible. It was heavily overexposed, the background was entirely blown out, and it offered zero definitive clues about the surrounding environment. Faced with this glaring lack of context, your brain was forced to make a blind guess about the lighting. And this is where neuroscience reveals something truly fascinating about our individuality. Scientific studies conducted in the wake of the phenomenon discovered that your brain's default lighting assumption is largely dictated by your personal visual habits, your age, and even your biological chronotype. Think about your daily routine. If you are an early bird who spends a significant amount of time outdoors in natural blue sky daylight, your visual cortex has essentially been trained to expect a blue illuminant. When forced to guess the lighting in that ambiguous photograph, your brain defaults to what it knows best. It subtracts that blue daylight, leaving you staring at a white and gold dress. Conversely, if you are a night owl who spends most of your waking hours indoors, surrounded by warm yellowish artificial light, your brain has a completely different default setting. It assumes the photo is bathed in that familiar glow, subtracts the yellow, and presents you with a black and blue dress. You are not just looking at a piece of clothing, you are looking through the accumulated lens of your entire life's visual history. Your personal routine literally wired your brain to perceive reality differently than the person sitting right next to you. So what does a decade-old internet debate and carefully constructed optical illusion actually teach us? It proves that the world you see right now, the device you are watching this on, the room you are sitting in, none of it is being piped directly into your mind as an objective truth. Your eyes are capturing raw, ambiguous data, but your brain is the ultimate director, constantly editing, filtering, and actively constructing the visual world in real time. The dress phenomenon was just a quirky meme. It was a rare, undeniable glitch in the matrix of human perception. It pulled back the curtain on the neurological reality that our vision is fundamentally subjective. Every color you see, every shadow you perceive, is an educated guess shaped by your biology, your environment, and your unique lived experience. We are all essentially walking around in our own custom-built virtual realities, completely convicted that what we see is the absolute truth. We talked about it some time ago from the purple color perspective. You can check out the video here if you like to go deeper into the rabbit hole. So, the next time you find yourself absolutely certain about the reality in front of your eyes, just remember the dress. The world isn't always what it seems, as some aspects of reality are just the construct of the mind. Oh, and by the way, the color of the dress is black and blue. That will be all for today. Thanks for watching. If you want to see more in the future, hit the subscribe button and ciao!